This is SpaceTime, Series 28, Episode 52, for broadcast on the 30th of April 2025. Coming up on SpaceTime, the strange mystery of Titan's river deltas. A new study unveils the volcanic history and clues to ancient life on Mars. And rare earth metals discovered in the atmosphere of a glowing hot exoplanet. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists are looking for the Saturnian moon Titan's missing river deltas. For researchers who want to learn about the geological past of a planet, river deltas are a great place to start. See, deltas gather sediments from large areas into one small place. There they can be studied and reveal climate, tectonic histories, or even signs of past life. And that's why NASA sent its most recent Mars rover, Perseverance, to Jezero Crater, home of a prominent and well-preserved river delta. And it's also why planetary scientists are so interested in finding deltas on Saturn's moon Titan. Titan is a unique place in our solar system. It's the only planetary body in our solar system other than Earth that has liquid rains that form rivers and streams across its surface and eventually flow down into lakes and seas. But unlike the Earth, on Titan the liquid isn't water but methane and ethane. See, Titan's so cold, water is frozen solid, forming much of the bedrock. Still, because river deltas are a great place to study an area's history, planetary scientists have been interested in finding river deltas on Saturn's moon Titan. Like on Earth, river deltas on Titan are likely to be a treasure trove of scientific data. But there's one problem. It seems Titan is largely devoid of river deltas, despite its large rivers of liquid methane and ethane. So a new study, reported in the Journal of Geophysical Research Planets, has been trying to understand Titan's strange geography and why it's so different to other worlds like the Earth and Mars. The study's lead author, Sam Birch from Brown University, says while disappointing, this absence of river deltas on Titan does raise a host of interesting questions. See, Birch says scientists have always taken it for granted if you have rivers and sediments, you're bound to get river deltas. But it seems Titan is very weird, making it a great playground for studying processes scientists thought they understood, but clearly don't. Titan is the largest of Saturn's 274 known moons. Its thick nitrogen and methane atmosphere gives rise to a host of Earth-like climate and weather features. Scientists first learnt of Titan's clouds, wind, rain, rivers, lakes and seas during the Cassini spacecraft flyby in 2006. Peering through Titan's thick atmosphere with its synthetic aperture radar, Cassini revealed sputtering channels and large flat areas consistent with large bodies of liquid. But largely missing from the Cassini images were deltas, even at the mouths of large rivers. But it wasn't clear, however, whether these deltas were truly absent, or whether they just didn't show up in the Cassini data. See, the problem with Cassini's data is that shallow liquid methane is largely transparent in any images. So, while the images could see the broad seas and river channels, it's harder to confidently make out coastal features. That's because it's difficult to see where the coast ends and where the seafloor begins. For the study, Birch developed a numerical model that simulates what Cassini would see if it looked at a landscape which scientists already understood well, planet Earth. In the model, the water in Earth's rivers and oceans was replaced by Titan's methane liquid, which has different radar absorption principles compared to water. Birch says he basically made synthetic images of the Earth that assumed properties of Titan's liquid instead of Earth's. Once they see the transformed images of a landscape they know, they can then go back to Titan and better understand what they're looking at. But the researchers found that the synthetic images of Earth clearly resolved large deltas and many other large coastal landscapes. So if there are deltas on Titan, the size of the one, say, at the mouth of the Mississippi River, scientists should be able to see them. And if there are large barrier islands, similar coastal landscapes like those seen along the American Gulf Coast, they should be able to see those too. But when Birch and colleagues combed over the Titan images in light of the new analysis, they came up mostly empty. Aside from two probable deltas near Titan's South Pole, the rest of the moon's rivers were entirely delta-free. The authors found that only about 1.3% of Titan's large rivers that terminate at coastlines have deltas. In contrast, on Earth, nearly every river of similar size has a delta of some description. It's still not entirely clear why Titan lacks river deltas. The fluid properties of Titan's rivers should make them perfectly capable of carrying and depositing sediment. Now, it could be that sea levels on Titan rise and fall so rapidly that deltas are smeared across the landscape more quickly than what they can build up at a single point. Winds and tidal currents along Titan's coast may also play an equally large role in preventing delta formation. And missing deltas aren't the only mystery raised by the new research. The new analysis of Titan's coastlines revealed pits of unknown origin deep within lakes and seas. The study also found deep channels on the floors of the seas that seem to have been carved out by river flows, but it's not clear how they got there. Now, all of these surprises are going to require a lot more research in order to fully understand them. This is SpaceTime. Still to come, a new study unveils the volcanic history of the red planet Mars and rare earth metals discovered in the atmosphere of a glowing hot exoplanet. All that and more still to come on SpaceTime. This episode of SpaceTime is brought to you by NordVPN, our official VPN partners and the ones we trust right here on the show. These days, it doesn't take a hacker in a dark room to compromise your online safety. In fact, every time you connect to a public Wi-Fi at a cafe, an airport, or even a hotel, your data could be exposed. Passwords, email, and even your personal information is all vulnerable. And that's where NordVPN comes in. NordVPN protects you with world-class encryption, keeping your online activities private and your data safe from prying eyes, no matter where you are. Plus, with NordVPN, you can stream your favorite programs securely, access content globally, and even avoid annoying bandwidth throttling. And right now, we have an exclusive deal for SpaceTime listeners, up to 74% off your NordVPN plan, plus 4 extra months free. And it all comes with a 30-day money-back guarantee. So, protect your data and protect your freedom. Head now to nordvpn.com/spacetime. That's nordvpn.com/spacetime. Your gateway to a safer, freer internet is NordVPN. A new study has revealed that the floor of the red planet's Jezero Crater is composed of a diverse array of iron-rich volcanic rocks. The new research, reported in the journal Science Advances, is providing fresh insights into the crater's geological history. The observations by NASA's Mars Perseverance Rover are providing scientists with their best chance yet to uncover signs of ancient life. The study's lead author, Michael Tice from Texas A&M University, says that by analysing these diverse volcanic rocks, scientists have gained valuable insights into the processes which shape this region of Mars. Tice says it enhances science's understanding of the planet's geological history as well as its potential to have supported life. Perseverance landed in Jezero Crater back on February 18, 2021, as part of the Mars 2020 mission's search for signs of ancient microbial life on the red planet. The rover's been collecting core samples of Martian rock and regolith for a future sample return mission and analysis back on Earth. Meanwhile, scientists like Tice are using the rover's high-tech tools to analyze Martian rocks in situ to determine the chemical composition and detect compounds that could be signs of past life. The 6-wheel car-sized mobile laboratory also has a high-resolution camera system that provides detailed images of rock texture and structure. But Tice says the technology is so advanced compared to that of past Mars rovers that they're now gathering new information, detailed chemical analysis, mineral compositions, and even microscopic textures at unprecedented rates. Tice and colleagues analysed rock formations within the crater to better understand Mars's volcanic and hydrological history. The authors used an advanced spectrometer called Pixel to analyse the chemical composition and textures of rocks at the Maz Formation, a key geological area within Jezero Crater. And the author's analysis revealed 2 distinct types of volcanic rocks. The first type, dark-toned and rich in iron and magnesium, contains intergrown minerals such as pyroxene and plagioclase feldspar with evidence of altered olivine. The second type, a lighter-toned rock classified as trachyandesite, includes plagioclase crystals with a potassium-rich ground mass. Now, these findings indicate a complex volcanic history, one involving multiple lava flows with varying compositions. To determine how these rocks were formed, the authors conducted thermodynamic modelling, a method that simulates the conditions under which the minerals were solidified. Their results suggest that the unique compositions resulted from high-degree fractional crystallization, a process where different minerals separate out of molten rock as it cools. They also found signs that the lava may have mixed with iron-rich material from the Martian crust, further changing the rock's composition. Tice says the processes seen here, fractional crystallization and crustal assimilation, also happen in active volcanic systems on Earth. It suggests that this part of Mars may have had prolonged volcanic activity, which in turn could have provided a sustained source for different compounds used by life. The discovery is crucial to understanding the red planet's potential habitability. See, if Mars had an active volcanic system for an extended period of time, it might also have maintained conditions suitable for life for long periods of Martian history. The authors carefully selected their sample rocks because they contain clues to the red planet's past environments. But the real data will come with a future Mars sample return mission. A collaborative effort between NASA and the European Space Agency aiming to bring back samples within the next decade is now in the planning stage. Once on Earth, scientists will be able to access these materials using more advanced laboratory techniques, allowing their analysis in far greater detail. This is SpaceTime. Still to come, rare earth minerals discovered in the atmosphere of a glowing hot exoplanet. And later in the science report, a new study shows that AI chatbots make inconsistent moral judgments. All that and more coming up on SpaceTime. Astronomers have discovered rare earth metals in the atmosphere of Kelt 9b, one of the hottest known exoplanets. Back in the summer of 2018, a joint team of astronomers from the University of Bern and Geneva found signatures of gaseous iron and titanium in Kelt 9b's atmosphere. Now, these researchers have also been able to detect traces of vaporized sodium, magnesium, chromium, and the rare earth metals scandium and yttrium. Exoplanets are planets outside our solar system that orbit around stars other than the Sun. Since the discovery of the first exoplanets in the mid-1990s, over 5,000 have now been found. And many are extreme compared to planets in our solar system, such as hot gas giants that orbit incredibly close to their host stars, sometimes with periods of less than a few days. Now, these so-called hot Jupiters don't exist in our solar system, and their presence has defied predictions of how and why planets form. For more than 20 years now, astronomers from all over the world have been working to understand where these planets come from, what they're made of, and what their climates must be like. The planet's host star, Kelt 9, is located 650 light-years from Earth in the constellation Cygnus the Swan. Its exoplanet, Kelt 9b, exemplifies the most extreme of these hot Jupiters. That's because it's orbiting very closely around a star that's almost twice as hot as the Sun, and therefore the atmosphere of this hot Jupiter reaches an incredible 4,000 degrees Celsius. Now, in such heat, all elements are almost completely vaporized, and molecules are broken apart into the constituent atoms, very similar to the outer layers of stars. Now, this means that Kelt 9b's atmosphere contains no clouds or aerosols, and the sky is clear and mostly transparent to light from its host star. The atoms that make up the gas of the planet's atmosphere absorb light at very specific wavelengths in the spectrum, and each atom has a unique fingerprint of colors that it absorbs. These fingerprints can be measured with a sensitive spectrograph mounted on a large telescope, allowing astronomers to determine the chemical composition of atmospheres of planets many light-years away. Now, for this study, the authors used the HARPS North spectrograph, mounted on the Italian National Telescope on the island of La Palma. They found iron and titanium atoms in the hot atmosphere of Kelt 9b. One of the study's authors, Kevin Heng from the University of Bern, says he then went to re-examine the Kelt 9b system in order to both confirm their previous detections, but also to search for additional elements. A new survey reported in the journal Astronomy and Astrophysics involved 73 atoms, including some so-called rare earth metals. These substances are less common on Earth, but are used in many advanced materials and devices. The authors predicted that the spectrum of this planet could well be a treasure trove, where a multitude of metals might be detected that have not been observed in the atmospheres of any other planets before. After careful analysis, the authors indeed found strong signals of vaporized sodium, magnesium, chromium, and the rare earth metals scandium and yttrium. The latter three of these have never been detected robustly in the atmosphere of an exoplanet before. The authors were also able to use these signals to estimate at what altitude in the planet's atmosphere these atoms were absorbing, and to learn more about strong global wind patterns high up in the planet's atmosphere, wind patterns that are blowing material from one hemisphere to the other. This report from Kevin Heng and Jan Schreemakers from the University of Bern.
I'm Kevin Heng. I'm a theoretical astrophysicist who is interested in exoplanets, planets around other stars beyond our solar system. I'm currently a professor of astrophysics at the University of Bern in Switzerland and the director of his Center for Space and Habitability.
My name is Jens Schreemakers. I am from the Netherlands, but I've worked at the Center for Space and Habitability in the University of Bern and the Observatory of Geneva. My interest is the study of the atmospheres of exoplanets using very large telescopes that are spread out all over the world. Kelt 9b is a very hot gas giant planet. You can imagine it as a planet that is somewhat similar as Jupiter in our own solar system, but it is located very close to its host star. And that itself is not necessarily special because we know of many planets that are like this. We call them hot Jupiters. But this planet is orbiting a particularly hot star as well. And that means that it is the hottest exoplanet that we know exists today. So what we have discovered in the atmosphere of Kelt 9b is that it contains, in gaseous form, heavy metals such as iron, titanium, chromium, and other heavy metals that have never been observed in the atmosphere of a planet before. In the atmosphere of Kelt 9b, we have detected a number of heavy metals, and two of these are what we call rare earth metals, scandium and yttrium, and these have not been observed in the atmosphere of any planet before. To study what the atmosphere of a planet is made of, astronomers make use of a technique called spectroscopy. So the light from the exoplanet system will reach our telescope. And the telescope, instead of making a picture, it will feed the light into the instrument called a spectrograph. And the spectrograph acts to disperse the light into its individual colors, like a rainbow. Now, this rainbow will tell us how bright the object is at each of its individual colors. But the material that is present in the planet will absorb colors at very specific places. And for many atoms or species, that can be a very complicated pattern of colors that is absorbed. So you can think of that as some sort of a fingerprint. Every atom has its unique pattern of colors or its unique fingerprint that it absorbs. So by passing the light through a spectrograph and seeing at which colors the light is absorbed, we will be able to distinguish which elements are present in the object, even if it's many light years away.
So one of the reasons why we are so interested, almost obsessed with this technique is because it's very general. It makes us think of molecules and atoms as fingerprints of an exoplanet. So once you accept that idea, you can use this idea to search for anything you want. In the case of Kelt 9b, we searched for metals, but you could imagine in the future that we could use it to search for biosignatures, so signs of life in another exoplanet.
That's Kevin Heng and Jan Schreemakers from the University of Bern. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study suggests that you can now blame when you were conceived for how you store fat. A report in the journal Nature Metabolism has found that people who are conceived during colder seasons may grow up to store fat differently in their body, putting them at an advantage when it comes to weight loss. The authors investigated the density of different types of fat in 683 people and then compared them based on whether they were conceived in the warmer or cooler half of the year. They found that those conceived in cooler months generally showed higher levels of brown fat activity, which is used to regulate body temperature and which has been linked to more energy expenditure, more heat production, less fat accumulation around body organs, and lower body mass index. Paleontologists have for the first time analysed the soft-bodied tissue of a fossilised 183 million-year-old plesiosaur. The results, reported in the journal Current Biology, showed that the long-necked marine reptile had both smooth and scaly skin. This was likely so that it could swim rapidly and move along rough seabeds. Plesiosaurs lived in the world's oceans for much of the Mesozoic era, between 203 and 66 million years ago. These reptiles could grow up to 12 metres long. They fed on fish, and they moved much like sea turtles using 4 paddle-like flippers. Until now, little had been known about the external anatomy of plesiosaurs. Fossilised soft tissue such as skin and internal organs is exceptionally rare. The specimen was found near Holzmaden in Germany and provides unparalleled insights into the appearance and biology of these long-extinct reptiles. A new study has found that chatbots make inconsistent moral judgments. A report in the Journal of the Royal Society Open Science presented large language models with a moral dilemma a self-driving car might encounter and then prompted them to choose the better of 2 options. For example, either hitting and killing the pedestrian or swerving into a barrier and killing the car's occupants. However, the scientists found that small changes to the prompts, like labelling options with letters instead of numbers, is all that it takes for a chatbot to choose differently. The authors say previous research to identify chatbots' moral biases treated them as having moral values, like humans, but this new study shows their behaviour is fundamentally different. They suggest future research should assess the reliability of large language models before trying to understand their behaviour. YouTube is celebrating its 20th birthday, 2 decades of everything from funny cat videos to major historical moments in time. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Yes, they're celebrating 20 years in the business. They're the number 2 most visited website on the internet. It's the place you go. They have competition from Rumble and other places, but YouTube is Google. Google is still, despite all the AI, despite ChatGPT, despite all the things that are happening, Google is number 1. And YouTube is number 2. People use
YouTube is owned by Google anyway.
Yeah, that's right. And YouTube is used like a search engine. So many people discover how to do things by, it's monkey see, monkey do. You see someone on the internet showing how to fix your car or fix something that you have that, you need the instructions to, and people bring up YouTube and watch a video there. But over the 20 years, there's a few different interesting milestones. The first clip was 19 seconds long, called Me at the Zoo, and you can still watch that today. But there are now over 20 billion videos on YouTube, and that's music and shorts and podcasts.
Will anything beat a cat playing a piano?
Well, that, of course, was one of the famous videos as well. A lot of the memes and things that you now see on X or other places are little snippets taken out of, popular videos. But there's some interesting stats. There are over 20 million videos uploaded daily to YouTube. And so many people have their own YouTube shows and have become stars like Mr. Beast. Both YouTube Music and YouTube Kids are 10 years old each this year as well. So that's sort of halfway through YouTube's lifespan. And there's a lot of music videos that have hit the billion views club. There's more than 300 of those. Number 1 is Adele with Hello. Number 2 is Ed Sheeran with Shape of You, and Luis Fonsi with Despacito. But YouTube is 20 years old, and it'll be interesting to see how it changes in the next 20 years.
The other big news, we just covered it last week, but it's happening again, another update for Samsung.
In early April, there were a number of updates for, I think, the S24 series in different parts of the world to get One UI 7. But in Australia, we've had to wait until the last week of April for them to arrive here. So that's One UI 7 and Android 15. There's a lot of extra and newer AI features that have improved over what was delivered last year. But interestingly, Android 16 is going to be released about 3 or 4 months earlier. And the big Google I.O. is coming this month. And so this is where Google is going to unveil and showcase Android 16. Normally it comes when the new Pixels arrive, but they've decided to amp up the pressure on Apple and everybody else, and they want to have Android 16 ready to go. So we're going to see a whole stack of new features, but this also means that One UI 8 is going to arrive as well. So a lot of people who are just upgrading to One UI 7 will, in a few months' time, get One UI 8. Hopefully, we won't have to wait till 2026 for that. But Google has decided that it really wants to accelerate the Android timescale. So it looks as though they're going to be beating Apple every year by launching the newest version of Android before the newest version of iOS. So the big battle between Apple and Google continues. And at the moment, Google and Samsung are winning the AI race much more than Apple is. In fact, we're yet to see what Apple is going to do because a lot of the big AI features that were meant to come by 18.4, the iOS 18.4, didn't arrive. Apple was very embarrassed about that. And yet on Samsung and Google devices, you can do a lot more with Google Gemini. You can hold the phone up and look at different things and it can explain to you what it's saying. In fact, one of the features, you'll be able to upload a video into Gemini with Android 16 and it can tell you what it sees and help you understand what it is you're watching. And it's going to be great for consumers globally.
That's Alex Zaharov-Reutt from Tech Advice Start Life. And that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.